Hello everyone, we are in AMA1501 Group B.1. Here are the names and student numbers of our team members. Now let's talk about the group presentation questions for Chapter 2. Okay, now I will explain question 2. We should focus that there are 5 projects about transportation and 3 projects about marketing. The research team needs 4 projects. The team will be assigned at least 2 projects about marketing. So that means we have to calculate 2 cases. The team will be assigned 2 projects about marketing, and the team will be assigned 3 projects about marketing. So we need to calculate the total number of possible events that the team is assigned 2 or 3 projects about marketing, and the total number of possible events. Now let's see the solution of question 2a. So first of all, we are going to talk about these 4 events, and we are going to call them A, B, C, D. Just like this, events A, B, C, D is follows. The probability of B is equal to NB divided NA is equal to 3 out of 70. And the probability of C is equal to NC divided NA is equal to 7 years. And the probability of D is equal to probability of B plus probability of C, and equal to 2 out of 35. So that the probability that the team will be assigned at least 2 projects about marketing is 2 out of 35. Now let's see the question 2c. We should focus that in the company managerial staff accounts for 25%, and the technical staff accounts for 60%, and the clerical staff accounts for 15%. And the 65% of managerial staff were satisfied with the recent pay adjustments. 78% of technical staff were satisfied with pay adjustments, and 60% of clerical staff were satisfied with pay adjustments. So we know that what percentage of the company staff are technical and what percentage of technical staff are satisfied with the pay adjustments. And we want to know the probability of taking 1 person from the employees who are satisfied with the recent pay adjustments, and that person is a technical staff. Now let's see the solution of the question. We can use Bayes' theorem and binomial distributions to solve this problem. Again, the 4 events are first represented by letters. The events A, B1, B2, B3 is follows. We noticed that the probability of B1 is 0.6, and the probability of A occurring under the condition that B1 occurs is 0.78, and the probability of B2 is 0.25, and the probability of A occurring under the condition that B2 occurs is 0.65, and the probability of B3 is 0.15. And the probability of A occurring under the condition that B3 occurs is 0.6. So that the probability of B1 occurring that condition that A occurs is equal to the probability of B1 and A divided the probability of A. Next, we can use the Bayes theorem so that the probability of B1 occurring that under the condition of A occurs is 936 divided 1441. Next, we can use the binomial distribution. The variable x follows the binomial distribution. So we let C is equal to events that exactly one of the 3 is a technical staff when we selected the 3 staff randomly from those who are satisfied with recent salary adjustments. So that The probability of C is equal to 1C3 multiply 936 divide 1441 multiply 505 divide 1441 and multiply 505 divide 1441, and so the probability of C is equal to 0.23932499172. Therefore, the probability that exactly one of the three is a technical staff is 0.23932499172. Next, Hu Ruoxi will explain question B and C.
Thank you so much for Niange's sharing. I'm Hu Ruoxi, so I'm going to talk to sim to Q2B and Q2C. So for the Q2B, we can know from the title that there is a business schools with 3 departments, and there are 4 teams from each of the 3 departments, and we have to randomly choose 2 teams to participate in a business competition. So what is the probability that both teams are from the same department? We first consider that the 3 departments are A, B, and C. So it has totally 12 teams. And for each of department, we can name it as A1, A2, A3, A4, B1, B2, C1, C2, just like this. And we also consider K is a both team from the same department. So we already know 2 teams are randomly chosen, and there are 12 teams in total. So we have to choose 2 that can be formed from 12 teams, and it's shown like this. And we can get that the denominators, the amount of denominator is 16,6. And so we know that they have 3 departments, A, B, and C. And the teams from the same department, A, B, and C, we don't know what team, but it all has this kind of possibilities. So we just choose 1 over the 3 choice, and is 1 that be formed from 3. And also we consider that we choose A. And there are 2 teams over 4 and 0 randomly. So it's 2 that can be formed from 4. And we can get the answer is 3 over 11. And for the Q2C, there are 3 people who are candidate for the office of president. And for Mr. President, Mr. Parker, Ms. Poe, their data of being elected are as follow. And respectively for the data of possibility of pay raise, and if those people are elected, is also shown in this title. So the question is, if there is a pay raise after the election, who has the highest probability of being elected as the president of the company? So this data is what we already know, that A equal to Mr. President elected, B is Parker, C is Powell, and X, we consider that there is a pay raise after election. So for the probability of A is 0.32, for B 0.46, for C 0.22. And this data is because we just assume that A is happened, which means that Mr. President is elected. So what is the probability of X? As shown in title, which is 0.81. And for the B, for the C, is also like this. So if there is a pay rise after election, who has the highest probability of being elected as a president? So we can look at this picture. For the circle X, it means that there is a pay raise after election. And we have to compare the area with yellow, red, and green. We have to compare them and decide which area is bigger. That means the higher probability. So we already know this formula, and it's also same as when A turn to B and C. So this one, the conditional probability of A giving X, it means that X already happened, which is there is a pay raise of the election. So what is probability of A? What is probability of being elected? This is a formula that I already showed you, and we can just multiply this one and this one. And because we have to add B, C, A, that we can, if we only can have to divide this part, that we can know the probabilities of Mr. President if she is elected. And it also gets the same methods as B and C, which is X happen, and the probability of the B of the C. and it can show just like this. We just get the answer which part has the higher probability. And the answer now is clear. Mr. Percy, because this one is the biggest one, so he has the highest probability of being elected as the president of the company. So that's end of my exercise. I'm going to turn to Hu Yuchen for proper number mock 2 Q2B.
Thanks, Olivia. Okay, now there is Hu Yuchen, and I'm going to talk about the mock 2 Q2B. Okay, let's look at the question topic. Every Friday morning, OMB Security delivers page from a local bank to each of 5 firms in a certain area. Having collected the necessary money from the bank, a security one visits the 5 firms in turn, but as a precaution against robbery. The same rule is now used on each occasion. Immediately prior to each Friday's delivery, the van driver chooses at random, according to a procedure established by the operations manager, the order in which the 5 firms will be visited. So, what can we get from the topic? There are 5 firms, and the one with its 5 firms in turn, and the same route is not used on each occasion. And the van driver will choose at random, and they will visit all 5 firms. So let's look at question 1. What is the probability of the one following a particular route on any specific occasion? If we wanted to know this probability, we should know how many routes are there at first. So we need to rank these 5 firms. Why I rank them? Because one kind of order equals to 1 route. Okay, then how to rank them? Then we need to use the permutations rule. Is permutation of a side of objects is any arrangement of these objects in definite order, which we have learned in lecture 2. And this is a formula for it, for the permutations rule. Okay, then the number of permutation of 5 firms is 5p5, and according to the formula, it finally equals to 120. And then we let the event A equals to the one of following a particular route. So the probability of event A equals to 120th, 120. Sorry, 120th. Okay, then let's move on to the question 2. What is the probability of one following different routes on each of 4 consecutive weeks? From question 1, we know the total number of routes is 120. So in week 1, we can choose one from those 120 routes. But according to difference, we cannot choose that one we have used in week 1. So in week 2, we can only choose one from other 119 routes. Similarly, in week 3, we can choose one from the rest of 118, and in week 4 is 117. So, and then we let the event B equals to the one following a different route on each of 4 consecutive weeks. Then we can know that the probability of event B equals to 120th 120 times 120th 119 times 120th 118 times 120th 117, and it finally equals to 0.9508. That's the answer of question 2. So my part is over. Thank you. And then I'm going to turn to listening. Thank you.
Thanks for my partner's presentation. Now I will explain mock 4 Q2A to you. Paul has prepared 5 questions in descriptive statistics 10 questions in probability and 12 questions in probability distributions. From these prepared questions, 9 will be selected randomly for the quiz of statistics that will be held next week. What is the probability that the quiz will consist of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distributions? The result consists of 3 parts: descriptive statistics, probability, and probability distribution. So multiplication rule is applied in this case. Since 5C2 equals to 5 factorial divided by 2 factorial multiplied by 3 factorial, which equals to 10. For descriptive statistics, there are 10 possible results. Since 10C4 equals to 10 factorial divided by 4 factorial multiplied by 6 factorial, which equals to 210. For probability, there are 210 possible results. Since 12C3 equals to 12 factorial divided by 3 factorial multiplied by 9 factorial, which equals to 220. For probability distribution, there are 220 possible results. Set A equals to event that the quiz consists of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distributions. NA equals to 5C2 multiplied by 10C4 multiplied by 12C3. Set B equals to the total possible results. NB equals to 27C9, which equals to 27 factorial divided by 9 factorial multiplied by 18 factorial. So PA equals to NA divided by NB, which equals to the result shown on the screen. According to the statements above, the probability that the quiz consists of 2 questions in descriptive statistics, 4 questions in probability, and 3 questions in probability distribution is shown in the screen. That's mock 4 Q2A. Now welcome my partner He Qiuran, who will explain Q2C to you.
Thank you for Funing's answer. This is He Qiuran. I'm going to talk about question 2C. Let's look at the question. A manufacturer receives large shipments of parts from 3 suppliers, A, B, and C. 30% of the shipments comes from supplier A, whose shipments contain 2.2% defective parts. 45% of the shipments come from supplier B, whose shipments contain 1.5% defective parts. The remainder of the shipments comes from supplier C, whose shipments contain 2.5% defective parts. The manufacturer receives a shipment, but doesn't know the source. A random sample of 10 parts from this shipment is tested, and 1 part of the sample is found to be defective. Calculate the probability that this shipment came from supplier B. From text, we can know that 30% of the shipments come from supplier A, 45% of the shipment come from B. So the percentage of the shipment from C is equal to 100% minus 30% minus 45%, equal to 25%. And focus on here, we can know the shipment from A contains 2% defective parts. The shipment from B contains 1.5 defective parts. The shipment from C contains 2.5% defective parts. Let's D be the event that a shipment is found to be defective. So we have the probability of D given A equal to 2%, probability of D given B equal to 1.5%, and the probability of D given C equal to 2.5%. And then the question is a random sample of 10 parts from this shipment is tested, and 1 part of the sample is found to be defective. Calculate the probability that this shipment came from supplier B. Let's ask about the probability of a shipment is found to be defective, which came from supplier B. So we find the answer should be the probability of B given D. By using the Bayes theorem and law of total probability, we can find the answer is the probability of B given D, which is equal to the probability of B intersect D divided the probability of the shipment is found to be defective. So the numerator should be the probability D given B multiplied by the probability of the shipment from B. And the denominator should be the probability D given A multiplied by the ships come from A plus the probability of D given B multiplied by the shipment from B plus the probability of D given C multiplied by the probability of the shipment from C is equal to the 0.335. So this question's answer is 0.335. Here is the information about Bayes theorem. That's all my solution.
So our group's presentation is over. Thank you for all your attention.